that's today, right? If I literally have not taught you anything new, today is the day you get something new. Okay, so my worry is a couple of those kids, and maybe it's an unfounded worry because I got a lot of smart kids in here. But my worry is that your attention will be close to zero because you think you know all this stuff, and all of a sudden comes some brand new stuff, and you aren't paying any attention. This is a whole bunch of brand new stuff. By the way, I would classify Grayson. I would classify today as a very easy class if you pay attention. If you don't pay attention, go ahead and hit if you don't pay attention, you will not be able to figure this out yourself. Okay, it's a couple formulas. It is new procedures, and it is absolutely positively new concepts. There's branches of mathematics. Well, the easiest branch is called arithmetic, abstract, multiply, and divide. You got a branch of math called algebra, solving for unknown variables. All variables are unknown. Solving for variables. You got geometry, calculating things to do with shapes. And then you have another branch called probability and statistics. We will be doing probability and statistics this chapter. All right. Probability and statistics. Okay. Brand new terminology, brand new words, brand new formulas today. Here we go. We're going to get the final word this Friday on what this week will, because it's changed, what this week will look like. You'll be taking some sort of test. I don't know the details yet because it's changed too many times, and I got tired of changing my slides. So more to follow. I'll give you the details after they tell me the details. All right, here's your homework. There's two parts. There's the written exercises and problems, meaning word problems. Don't panic. Word problems are all very easy. Very easy. So you have written exercises 2 through 12 evens, and then you have problems 2 through 8 evens. Thank you, Grace. Bless you. Now go use some hand sanitizer. All right, new symbols today that you've never encountered before and that are on your calculator. You just didn't even realize it was on your calculator before. You do not need a calculator today. And remember, Grayson, it's up here on, in case I change the slide. All right, we're ready? All right, here we go. Like I said, today is an easy day. It's got a weird word. You've never seen this before. Permutations. Okay, we get a formula for this. Okay. All right. I've already said this twice now. If you don't pay attention, you will not figure this out all by yourself. Think about this. You're at home, right? Quarantine's over. There's no COVID, and you want to go to the movies, right? And let's go see what's a good movie going right now.
Or no, Mortal Kombat.
Yeah, King Kong. I like King Kong. So let's go to King Kong. Now, let's pretend that it's the summer. Quiet, please. It's the summer, and your mom says, "Get out of the house. Here's some money. Go to the movies with your friends." Right?
Yes.
So I always say this because I literally live behind a movie theater type. You know where the Sky Sox Stadium is?
Yeah.
That Cinemark. I live behind that. I live over there. Right? So my kids could literally walk to the movie theaters. So sometimes in the summer I would like, here's $20, go see a movie. Get out of here because I want to play PlayStation. And if they stayed home, they would be playing PlayStation. All right, now stay with me. Listen. So to go from the house to the movie theater, well, you could walk, you could ride your bike, you could, I don't know, in big terms, you could get someone to drive you there. You have options. Today is a class about options. But I do have to get from the house to the movie theater. Now, if you're like me, you go to the movies, who wants to pay $10 for a soda, right? I'm gonna stop at the 7-Eleven, even though they say I can't do it. I'm gonna put a can of soda in my pocket and I'm going to the movie theater because I'm not paying. I'm not paying $10 for a soda. All right.
Yeah, no, what you do is you
It's higher than 5, less than 10. It's crazy expensive.
You
All
grab
right.
a bag, you put a whole bunch of candy at the bottom. you just
Back
eat
up
it,
here.
and then you-
Back up here. So now I've complicated things. Now I'm not going from my house to the movie theater. I'm going from my house, 7-Eleven, and from 7-Eleven going to the movie theater. Okay, great. Well, depending upon how your neighborhood is, many times you have more than one options to go from one place to the other. You can go the crazy route, like that's very scenic. You can go by the creepy guy's house, right? Or you can cut across a whole bunch of people's lawns and go the direct route, right?
Go to the direct route.
Now we're at 7-Eleven, we get our candy, we get a soda, now we go to the movie theater. You still have multiple options, right? You can go the crazy route, you can go a direct route, okay? What today's math and today's formula is about is how many options do you have? Like in total, how many options do you have to go from your house to the movie theater? Hands down, okay? How many options do you have? Well, one way you can do it, it's called, in math, it's called the brute force. Here's my map. It's literally called a map. We can draw on our map the different ways. Well, let's say, for instance, I do want to go by the creepy guy's house. Now I'm at 7-Eleven, and now I can either go the direct route or the circuitous route. I'm going to go that route. So how many ways did I just show you right there? Well, no, I mean, this is one way, right? This is one way to get to the movie theaters, right? So my count is now at 1. But remember, you don't have to go, or maybe you do want to go by the creepy guy's house. So if you go by the creepy guy's house again, but this time you want to go by your friend's house and pick them up, well, that's a different way than this, yes? So our count goes up. There's 2 different ways. But you never had to go by the creepy guy's house. You could have gone the direct route to the 7-Eleven. But once you're there, how many choices do we have? We got 2 choices, direct or circuitous. So our count goes up.
3,
And then
4,
4. Hold on. Now, here's where I'm starting to lose some people. This is important what we're doing. Okay. So now we're up to 4 different ways. I only need to go one way to get to the theater, but I found out there's 4 different ways. But I never went the long way, right? So now we go the long way, and I still have 2 more choices. So in total, how many choices are there? So if that's my map, I have 6 different ways to go to King Kong.
But also
Alright.
there is like 20,000 more that you could do.
And I would have to draw those on my map, okay? But if this is the map, then there's 6 ways of going to the movie. This is what today's class is about. No, you're not going to be drawing a map. You're going to be doing a calculation based upon the map, okay? 6 ways. Anybody notice something special about this number 6 in my map?
You multiply 3.
It sure looks like you're simply multiplying your choices together 3 times 2. And it turns out that that's exactly what's going on. And this is a large concept in math. We're going to write it down here in a second in box 1. Okay. This is called, write this down, box 1. This is called the counting principle. The counting principle says this. If you want to find out how many ways are there to do something, you take how many ways are there to do the first task, and you multiply it by how many ways are there to do the second task. Whatever the 2 numbers multiplied together is how many ways are there to do the entire task. This can be extended. It just doesn't have to be 2 different tasks. It could be 3 and 4 and 5 tasks. But you will still do the same process. You will take the number of ways to do the first thing times the second thing times the third thing times the fourth thing. It's basically you count up. That's why it's called the counting principle. You count up how many ways are there to do the first task. Multiply it by after you count how many ways are there to do the second task, and then the third task, and the fourth task. The counting principle never talks about more than 2 tasks, but there can be more than 2 tasks. I said today was easy because literally you're going to be taking 2 or 3 or 4 numbers together and multiplying them together. That's it.
That's all. Oh, that's
It does get slightly more complicated, but not much more. Does everyone have this written down?
no.
If there are m ways to do one thing and n ways to do another, then there are m times n ways to do the whole thing. That's called the counting principle. It's one of the fundamental things you learn in probability and statistics. We ready? All right, couple examples. Hey, you got 3 shirts and 4 pairs of pants. How many different outfits do you got?
Well,
You literally take how many of the first and you multiply it by how many of the second, and that tells you how many different outfits you have. That's the counting principle. You got 12 different outfits. Okay? 12 different things. If you're one of those weird fashionistas that says, I got to wear something different to school every day, right? Well, you need to have at least how many pairs of pants and how many shirts that are different from each other. No, 5 times 5 would be 25 different outfits. So if you want a different thing to wear every day of the week, how many shirts do you need?
102.
2 or 3. How many pair of pants do you need?
100.
2 or 3. And therefore you can wear something different to school every day. By the way, that would be 2 times 3 is 6. You got an extra one. All right. Do you see this thing right here? Look at the board. This is that picture that I just drew of going to the movies, except it's drawn without nice pretty pictures and a description. You have a starting point, you have a finishing point. You have a certain number of ways to go from the first to the second, and you have a certain number of ways to go from the second to the finish point. How many ways are there to go from the first to the second?
15.
3.
A little ahead.
How many ways to go from the second to the third?
5.
1, 2, 3, 4, 5. So how many ways?
15.
There's 15 ways to go from the first to the last. I said that this isn't hard if you pay attention. It's not. It's pretty simple. Okay? Questions on this? Yes, Abby. You can. By the way, there's a job and it's called a city planner. And there's people whose jobs there are to do this sort of stuff in a city. Like, for instance, people get very angry when they're driving on the road and all of a sudden the light turns red, right?
Oh, yeah.
So they have a job that literally does things like this. They're like, well, if someone lives in my city, then they can get from this part to this part, you know, what's the good routes? Am I holding them up? So they use this with time to figure out how long it takes to go from one position to the
Is
next
that
position.
why we have GPS now?
GPS has changed the fact that now we can visually see things a little bit clearer and more quicker, so we can pick alternate routes. That's not why we have GPS. The reason why we have GPS is because we want to blow people up with bombs. That's why we have GPS.
Let's do it.
Well, yeah, that's why we have it. Who invented GPS? The U.S. military. Why did the U.S. military invent GPS? Because location is very important for them, both for where they're at, so they don't, if they're on a Navy ship, they don't run into things. And if you're in the military, you're trying to send, unfortunately, bombs to a specific location, right? There's a crudely explanation. All right, we're off topic. All right. Buying cars. If you've ever been around your parents when they buy cars, they have options. So, for instance, if you want to buy this specific model is either, let me talk, is either a sedan or a hatchback. It comes in 5 different colors. And let me talk. You have a choice of 2 different body styles. You have 5 different colors. And each one of these comes in like the cheapo version, the kind of middle version, the one that has all the bells and the whistles, right? So how many different cars are there? 30. 2 times 5 is 10 times There's your counting principle. I don't know if you ever paid attention to Domino's, but they're famous for saying on their website, they have, I don't know what the number is, 46 million different types of pizzas.
Oh, yeah.
Do you know how they figure that number out?
They divide it.
How many types of crust times how many different types of sauce times how many different types of toppings, and what am I leaving out?
Times how many types of sizes?
Times sizes,
And
Oh,
also
sauce.
dough.
times dough.
I'm sorry.
That, I had that for things. So that's how they get that number. They're just using the counting principle. Okay. Do we understand the counting principle?
Yeah.
All right. Yes.
So, if you go back to that, if you like were to like count it up, like that car plus that.
Yeah, this would be the same thing as the going to movies thing. It's just how many different routes.
So if you do that, you put 18.
It doesn't, because remember, this could either be black, red, 1, 2, 3, so there. And then each one of these would have to go 1, 2, 3. So we get, each one of these has that many choices just for that one thing. And then you go to the red. And then I gotta do it for this card, right? This is why the counting principle makes this a whole lot easier. I'm not drawing silly little lines. I'm just multiplying some numbers together. There would be 30 total lines when we're done. Okay. All right. Do box 3 all by yourself. Go. Box 3 all by yourself. It's just words, no pictures.
What's 14 times 3?
14 less than 14 times 4. All right, how many pizzas?
42.
They add up very quickly, very quickly. All right. Are we ready to move on?
Yes.
Okay. The next two are, if there's anything challenging, it's the next two, and they're not that much more challenging. Here we go. New definition, write this down, box 4.
Oh, gosh. Okay.
First of many different weird words. It's called a permutation. It's when I take a number of things and I put them in a specific order, like what teachers do with seating charts.
Oh, no.
I take 30 kids and I don't put them in any order. I put them in a specific order. 30 kids right now are seated specifically in one seat. I did a permutation.
Yeah, everybody should just did it one.
There's actually 33 in here, but 3 of them are not here. 5 of them are not here, sorry. My 2 e-learners and then Callie, Avery, and
Well, they're not in our class anymore.
no, they're still in your class. They're just not physically here. Right now, they're taking their test right now that you took yesterday. They're still in this class. though.
Yeah, they moved.
No, they
classes.
moved to.
All they did was move to the other class. They're still taking course 2 in this class. They're doing it online
On Microsoft.
because there's only 30 seats in here and I had 33
I thought it
kids.
was like a test thing.
No.
They were like-
All right, permutations. That's literally what you're doing. Now, if instead I said, I got 30 kids, sit wherever you want, order doesn't matter, that is called, anybody know?
Mutation.
That's called a combination. A combination, it's kind of the same as a permutation. It's just when I don't care where you sit.
I wish that was.
I just have 30 kids. They can sit wherever they want. When you get to high school, that's my policy. I don't care. Next year, I'm going to say sit. Not on the floor, but sit in a chair. Okay?
Can I sit there?
What about the ceiling?
There's no chair up there. And there better not be
I
one.
can make it here.
All right. A combination is when order doesn't matter. Permutation means order does matter. Your mom says that you can invite 2 friends to go to the movies. That's a combination. Doesn't matter which 2 friends. When you get to the movie theater, you have to choose a seat. That's called a permutation. And then order does matter. Friend 1, friend 2, friend 3, or friend 3, friend 2, friend 1, or that's when order does matter. Today, we're only doing permutations. Tomorrow, we'll do combinations. But today, we will be doing a calculation of how many permutations? By the way, 30 kids in 30 seats. Anybody want to take a guess at how many different possible ways that you can sit in this classroom?
900.
Here's our guesses: 900,
9,000.
9,000, 900,000. We will see who's closest to the right answer
27,000.
at the end of class.
27,000.
30 people. How many different ways can I arrange you in this classroom? All right, here we go. So here's a simplified explanation of combinations and permutations. Here's our box of toys.
What?
I want you to take 2 of these toys and arrange them. Stay up here, please. There's 2 different ways to arrange them. There's combinations. You guys aren't paying any attention. Would you like to step outside and have a conversation about this? I said it's an easy class if you're paying attention. You're not paying attention. Combinations, permutations. You take a certain number of things and you put them in an order. Sometimes the order matters, sometimes the order doesn't matter. Okay, Jackson, pick 2 of those toys.
Square circle.
There's one possible combination. He chose a square and a circle, so did I. Now, is a square and a circle the same as a circle and a square? Order doesn't matter. So if I say square and circle, is that the same as circle and square?
Yes.
Sure is. That's the 2 toys you chose. What else could you choose? Okay. What else could you choose?
Square and triangle.
So how many different combinations are there if you choose 2 of these?
3.
There's only 3. Watch what happens when permutations. Permutation is when the order matters. That means I want you to pick 2 and put them down in a specific order. One specific order could be,
Square, circle?
is that the same if order matters as this one?
No.
This is where order matters. A square circle is not the same as a circle because order matters. It's like saying, I got to pick these 2 kids and put them in seats. Either he goes here or he goes there. Those are 2, I got 2 different possibilities. In combinations, I only had 1. Pick 2 people, follow me. You 2, follow me. Doesn't matter what their order is there. I got 2 students following me. That's a combination. When I say sit down in your seat in a specific order, not just sit where you want to sit, then that's a permutation. By the way, guess how many we'll have?
2.
6.
8.
6.
2.5.
We will have a total of 6. Here are 6 different permutations if I choose 2 of them. Yeah.
I figured out how many times.
What's your guess? 180.
180.
We shall see.
Hey.
All right. Today we were, oh no, no more guesses. We're going to be doing permutation. Tomorrow we'll do combinations. Today I will be giving you a series of things to choose from. You got to figure out what the permutations are. How many different are there ways to put those things together? That's called a permutation. Order matters. We got a formula. Okay. 3 things to choose from. Order matters. Right? I want you to pick 3. Well, there's only 3 cards there. Pick 3 cards.
Green.
Green, red, orange.
Or
Green, orange, red.
Or-
It's
Green,
green.
red, orange.
OR. Or
No, we think orange. Blue. That's red.
or
Orange, red, orange.
okay.
Orange, red.
This one's a little bit hard to do. If I ask you to draw it, you fill up your paper full of red, greens, and reds, greens, and blues, right?
Yeah.
There's an easier way of doing it. Watch this. If I ask you to pick 3 cards, guess what you got to do first? Like, think about it. Pick 3 cards. What's the first thing you do?
Look at them.
You pick 1 card, yes? If I have 3 cards in my hand and I say pick 3 cards, the first thing you do is pick 1 card. Well, how many choices do you have? Here's the 3 cards. How many choices do you have? The first choice you have how many?
1.
Then what's the next thing you do?
Pick another
second.
one.
How many choices do you have?
2.
You just chose a card. How could you have 3 choices?
Because there's 3 cards.
Yeah, but if you
Choose one thing.
This.
Now how many choices do you have?
2.
Oh, that's yours. Okay. The second time you make a choice, your second choice, there's my first choice, it's a card. I know what color it is. My second time I make a choice, how many cards do I have to choose from?
2.
So how many permutations are there? Doesn't this look like the let's go to the movies? 3 times 2 times 1. Guess how many different ways to arrange 3 cards? There are 6 ways. It's the counting principle. Therefore, it's 6. Question? By the way, doesn't matter which method. This is the easiest one. Why is this easier? Because you're not drawing anything. You're not physically acting it out. You're just multiplying 3 numbers together. What's your question?
So on the homework.
Well, now,
is it-
what's
no,
your
no, no,
question
it's
on
not a
this?
question on the homework.
What's your
It's-
question on this? All right, I'll get your
No, no,
question, but
is
not
it
right
written-
now.
Is it written
I
outside
will
the-
get to your question after this. All right. There are 6 different arrangements. There are 6 different arrangements. What if we had 4 cards? We had 4 cards, and I ask you to choose 3 cards. How many choices for your first choice? I got 4 cards now. How many choices for your first choice? How many choices for your second? And your last? So how many different ways are there to arrange 3 cards if you had 4 to choose from?
24.
Boy, that number went up really quick. We went from 6 to 24, and I only added 1 card. That's crazy. I only added 1 card, we had 24. If I say choose 4 cards, multiply by 1, it's still 24. Okay? We went from 6 to 24. That's a pretty big jump. Do you notice anything about this multiplication? Do you notice anything about this multiplication?
Oh, it's going down.
By.
What?
So for permutations, you're doing something very unique. You take how many there are, finish the thought, and then you go down by, and you put what between the numbers. That's what's going on. That's what's going on. What's going on for permutations, here are our 2 examples is, this is how many choices. You go down by 1 and multiply everything together. That's how you calculate permutations. 10 cards, that's the math you're going to be doing. Mathematicians a long time ago said, wait a minute, that's ridiculous. How many cards are there in a deck?
52.
So guess what I would have to do to figure out how many ways are there to arrange the cards? That's called shuffling. What would you have to do? By the way, that's a calculation that many people already know, and it's on your calculator. Agreed. Why do we know how many different possible permutations there are? Because someone's already done that calculation. And in probability and statistics, you do this calculation all the time. By the way, how many people are there in the United States?
1 million.
300 and something million. About half of them are girls and half of them are boys. There's more girls than boys. If you want to figure out how many possible people that you could date or marry in your life, guess what number you're working with? That would be a permutation, by the way. You're working with not tens, not hundreds. You're working with a number with millions. You're going to be multiplying that. Subtract 1, multiply. Subtract 1, multiply. Subtract 1, multiply. Boy, there better be an easier way of doing this than there is. That's the next concept. Okay. All right, just erase all the answers. All right. Write this down. The process that I just described, where I give you a number, you count down by 1, and then you multiply all of those numbers together, is something in math called a factorial. It's a short method. I don't want to write 150 million times 149,999,999 times 499,999,998. I want a shortcut method. It's called a factorial. It has a symbol. You can see it in front of you. Guess what the symbol for factorial is? There it is. It's an exclamation mark. Whenever you see an exclamation mark in math, it means you are doing a factorial. And yes, on your calculator is an exclamation mark. That's how you do a factorial. You take your calculator, you type 40, you hit the exclamation point, and it calculates that factorial. Boom, you're done. When the numbers are small, like 3 factorial, you can do it by hand pretty quickly. When the number is 40, your calculator will blow up. It's a very big number. Don't try to do 40,000 factorial. Your calculator won't like it, right? It's too big of a number. No, it won't actually blow up. But it will say, I don't want to do that calculation. All right, here's a nice easy one that we don't need a calculator for. 4 factorial, what does it mean? What does 4 factorial mean? 4, 3. Tonight for homework, you're going to have some factorials. Okay? Tomorrow, if you haven't found it, I will show you where it is on the calculator, but not today. All right, we good with this idea? Okay. What's 3 factorial? You can do that without a calculator. 6. Do you ever have to multiply by 1? Kind of a wasted effort, right? All right, so 3 factorial is 6. 5 factorial would be,
5 times 4 times 3 times 2 times 1 times 0 times.
no, we don't go to 0, because that would give us 0.
20.
5 times 4 is
20.
times 3
60.
times 2.
120.
We went from 6 to 24 all the way up to 120 really quickly. The numbers go up really quickly for factorials. Okay. 7 factorial.
7 times 6 times 5 times 4.
By the way, 7 factorial will be 7 times, take a guess, 6 factorial. 6 factorial would be 6 times 5 factorial.
Oh, yeah.
5 factorial
Now you're just making me.
would be 5 times 4. What was 4 factorial?
No.
4 factorial was
60.
24. 24 times 5 times 6 times. Sometimes that can speed the process if you ever have to do it by hand. Of course, that means you've memorized what those other ones are. And if you go into higher level math, pre-calculus and higher, you will have some of these memorized. Not many of them, but some of them memorized. By the way, what's 7 factorial? Not 50,000, 5,040. We went from 120 to 5,000 pretty quickly. The numbers get very large very quickly. All right,
Are you going to be able to use a calculator on the test?
not on a test, but I won't give you 12 factorial. All right. 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2.
Times 1.
You're multiplying.
Yeah, but he just should have said he was like. What? Okay.
All right, great. So what? Factorial. Well, remember, factorial is a way to do permutations. How many different ways could you choose 4 cards out of a deck of 10? Okay. Watch this. This is a different problem. We're off of factorials now. Here's a different problem. We have a way, because mathematicians don't like to write things out longhand. We have a way of writing this problem. That you have 10 things to choose from, and I want you to choose 4 and calculate the permutations. You ready for something new? Okay. There is how a mathematician, and it's on your calculator, by the way. There is how a mathematician would write this problem. You get a big capital letter P. Guess what the capital letter P stands for?
6. Or no.
Guess what the capital letter P stands for?
Permutation.
Permutations. N will represent how many things you're choosing from. How many things are we choosing from this problem? How many things are we choosing from? How many things are we choosing? R represents how many things you are choosing. Never seen this before. So a mathematician would say, I don't want to write all those words. I'm gonna write that.
I don't got that.
Tonight for homework, that's what they're gonna have written. This is what you're gonna calculate. So we better talk about this one. By the way, that's it in word form, that's it in notation. You can kind of see why I would rather have it in notation. Okay, I'll describe what you're gonna do here in a second. We okay with what it is? You better write this down too, because you're gonna forget which number is which. And you were on your papers, son.
Yeah.
Guess what the letter will be tomorrow?
C.
It'll be a C, and it's also on your calculator. C is going to be for combinations, P is for permutations.
But it's not on the calculator.
It is, you just don't know where to look.
Well, I did.
Could we stop the conversation now when I say you just don't know where to look? All right, we got enough copied down? You didn't have to write these words up here, but this just means 10, choose 4 of them, calculate the permutations. Turns out to be a pretty easy process. Watch me. Same problem. This is what, they're not going to give you this words, they're going to give you that. Here's how it's done. You got to make your first choice. How many cards are there to choose when you make your first choice?
4.
What? Here's the cards. How many am I asking you to choose?
4.
So the first time you do it, how many cards are there to choose from?
10.
How many cards do I have in my hand?
4.
2.
10 cards.
But it says 2.
I got 10 cards in my hand. So your first choice, you have how many?
4.
Hey.
Because there's 4 cards you can pick from.
Read it.
How many different ways could you choose 4 cards from a deck of
How many cards do I have in my hand?
10?
So when you make your first choice, how many cards are there to choose from?
10.
Oh. You just said to choose from. You said it's choose 4.
Do you need a
cards.
deck?
I'm not sure I can make this any easier. I am holding 10 cards in my hand. Choose 4 of them. When you make your first choice, how many cards do I have in my hand?
No.
10.
You just said you choose 4. You just took one
Somebody
out.
help me.
So it's
Here,
9.
I'm rubbing
you.
you.
I have 10 cards in my hand. I got 10 fingers. Here's my cards.
Yeah.
I want you to choose 4 of them, but you can't. You gotta grab one at a time.
Yeah.
So
have
when you
9.
make your first choice, how many choices do you have to grab from?
Hey. Oh.
See, I just gotta yell louder and it works.
But you said you had to take one.
You do.
Yeah, but then that's why I said 9.
But your
8,
first
7.
choice, you have 10 to choose from. Okay, now, Kai, how many do I have in my hand?
9.
So when I make my second choice, how many cards are there to choose from?
9.
When I make my third choice, how many cards do you have to choose from?
8.
When I make my last choice, how many cards are there to choose from?
4. Wait, what? Oh. 7.
What does this now look like? It's not permutations. This looks like box 1. This looks like,
The drawing you did earlier with the movie.
this looks like the counting principle. So guess what you're going to do with these numbers? This is how you calculate permutations. If it was 10, choose 10, it would be 10 factorial. But if it's not 10, choose 10, at some point you stop. Okay?
You just put that there and you have the answer.
You do.
Oh,
By the way, it's a pretty darn big number. There's only 10 cards. There's 5,040 different things that could happen if I have 10 cards and you choose 4 of them.
We just got that on the last one.
But I know. By the way, 30 kids choose 30. It's going to be bigger than that number. So for those of you who guessed 180, no.
No, sorry, I messed up. It's 9,
All right.
9, 9.
Let's do a different one. In a bag, I have the letters football,
Oh.
like Scrabble, right? I got the letters to spell out the word football. You can only choose 3 letters.
8.
How many permutations are there?
8.
Why are you just throwing out numbers?
Because I said
letters.
football. It's 8 letters.
If the answer is anywhere next to 8, I will eat my shoe. All right, here we go.
I'm saying football is 8 letters.
And I said, if you only choose how many letters, how many permutations, and you said 8.
No, I meant.
Oh my God.
All right, here we go. You got to make your first choice. So how many things are in the bag?
3. They're 8.
By the way, this would be 8, choose 3. So the first choice, how many?
8.
Second choice?
7.
7.
Third choice?
6.
Is it 8?
No.
What's the answer?
No. I said because it's 8
It's
letters.
56 times 6.
What's the answer?
56 to the.
What is the answer? Do the math. Let's go. What is the answer? What do you got, Abby? There are 336, not 8. There are 336 possible ways that you can draw 3 letters out of only 8. Look how big this number is compared to, I'm just drawing 3. There are only 8 to choose from.
Pretty close.
You got 9 friends. You can have 3 of them sitting next to you. Okay. How many different ways can you go to the movies and sit down in a seat?
9 ways.
This would be 9, choose what?
3.
9, choose 3. All right, first choice, how many choices?
9.
Second choice.
8.
Third choice.
7.
So how many ways can 3 people sit down in a movie theater if you had 9 friends to choose from?
72 times 7.
That is a crazy big number. Think about that. There's only 3 people in a movie theater. There's 504 different ways. And why it's so large because you had 9 different people to choose from. What was our last problem that I said we'd finish on? I said there's 30 kids in here.
Oh yeah.
I said there's 30 seats. So this would be 30, choose, there's got to be that. Hey, this is 30 factorial. Anybody found the magic key on your calculator?
No.
I know where it is. If I
Can I get my calculator?
I'm sorry, what is it?
It's
calculator.
well, it's an exponent.
It's in scientific notation. So what is it?
2.652.
So we'll call that 2.7 times 10 to the,
32nd.
I got to write 31 zeros. 31 zeros after that.
That's not that many.
There are 30 people in here. I don't even know the words for 30 zeros. There's 30 people in here. If I literally said every day we're going to have a different seating chart, 2, 7, and 30 zeros would be how many days it would take for everyone to sit in a different seat and have a different person next to them.
Sorry.
Do you understand how crazy that is? And the reason why I bring this up is because maybe not in your life right now, but when you're adults, you get a chance to do what?
Work.
To play the lottery. You know what I'm talking about?
Yeah.
Have you ever actually turned the television on when they're drawing the numbers?
No. Wait, what?
There are, I don't know because I don't play the lottery. There are these balls that go inside this big round sphere and they choose some out. The balls, I want to say there's 64 numbers. There's 64 numbers and they choose 6 of them.
Someone do the math.
It's 8.
Okay, here we go. No wonder.
64 times 65 times 66 times 60. Sorry, I'm counting the wrong way. 64 times 63 times 62 times 61 times 60 times 59 times 58.
My mic doesn't have a factorial.
Yes, it does. You just don't know where you're looking.
Where are
Now my calculator back.
Okay, I'm going to go back to what I said to him. Right? There are crazy odds to play the lottery, which is why the only person who gets rich playing the lottery is
The winner.
the state. Because the state relies on the fact that not many people know about permutations. There are so many millions of possible ways that those numbers can come out. The likelihood of you actually picking the right ones are as close to zero as possible. Oh, sure, somebody eventually wins, but millions upon millions upon millions of people play the lottery. One person wins.
It's
Guess who gets to keep the money?
Steve.
The state.
It's 380.
The point of the lottery is because, okay, personal opinion, is because there are fools out there who think that they can actually win the lottery.
Me.
Agreed. It's like saying, hey, I want to be an NFL football player because look, hey, there's an NFL football player right there. Millions upon millions upon millions of kids try to be football players. Only a handful of them get to be NFL football players. It's not that you shouldn't try to always do your best. It's just that your likelihood of you being that one person is so remote that you better have a plan B. Right? Same thing with lottery. There's plenty of people that play lottery for quote, quote, fun, right? And if you did it for fun and you do it responsibly, okay, I guess that's equal entertainment as going to the movies. But if you actually think you're going to win the lottery, you don't understand the math.
Wait,
Yeah.
I should do the math.
So, like, if at least 1 million people play the lottery, and then how much is each ticket?
About $1, I think. I don't play lottery. I don't know.
So,
I think it's $1.
yeah.
So you're
So
saying-
wouldn't the state eventually make more money? Because
They always make more money.
exactly, because like you're gonna, it's
They always make. And by the way, that's how many permutations there will be. If you and I play the same numbers, well, then we just reduce I'll show you tomorrow. I said this. And if you'd like to Google it, you can do it by yourself.
Okay,
All right.
I got a question.
Any questions on anything I did?
No,
You will skip this last one.
It's not something that you did.
Yeah.
It's, so the NFL drafting system,
Yeah.
it's like you can draft people on your phone for like the NFL. Say like you pay money to
Yeah.
and then they
I don't know.
silly.
All right, Donovan or anyone else? No one's online. If you do have any questions, send me a chat. What's up?
Whenever we take the test, we'll